stream button is red, doesn't that mean we're actually going?
That's
So
what
it
I
wasn't
thought,
red.
but when I click on it, then
Now
it
it says
says,
now my title bar says streaming live RTMP.
now there's 2 live streams. Let me go to the second one.
And you probably still have to click go live in YouTube to approve it.
I don't have the button anymore, though. That's what's weird. All right, we're definitely live. I just don't know. Okay, I can hear me. You say something.
Hello. Can you hear me?
Test 1, 2.
Test 1, 2. Whoa.
No, you're not in the audio stream.
Okay, so
No.
I can fix that. Are you watching it live then?
I am.
Okay, it's just somehow I can't see this. Is it the right channel?
Yeah.
Oh, now I see it. If I go to videos. Oh, that does work. And you didn't have to click go live?
No. It's like the go live button's been obsoleted or something.
Okay, so you can hear me through Skype, but not through
I haven't
XSplit.
done anything. Yeah, all I did was, once you went live, I clicked on it.
So here's what I'm going to do. I'm going to add a source. Device. Xperion webcam. So this is my direct webcam. I'm going to put that up there. And from this one, you should be getting you could be getting audio from the phone, and you'd be hearing that now. That'll be coming through to YouTube. But that's probably not the best audio sound. Let me choose a different device. Microphone array. This one will sound probably better. And I'll go stream only. And
you're in the stream now.
To be no. Whoa. There's an echo. I'm hearing it though.
All right, hold on. Let me mute the site. Because remember, when I go to monitor the site, I have to listen. So do you still have an echo? Say something. Something. Okay, I heard that.
Yes, there's definitely echo. So let me mute that one. And we'll see what that sounds like in YouTube on the other. 1, 2, 1, 2. Hey. Echo's gone. The echo's gone.
All right.
Okay, so I'm going to save this setting.
Yeah, I don't think it saves everything, but it just lets you know. Yeah, I think that only saves the scene settings, but not the audio settings, the global audio settings.
Okay. Let's call it. Let's hope it remembers each time anyway, right? So, and I'm going to go back to system settings.
Nothing's worked consistently. I mean, we've had a problem almost every show.
Yeah, I figure if we can just get it set up.
That's what I thought. But again, every time I go to do it, that's why we start at 1:30 is, you know. And it's not like I'm making changes, to make it work each time.
Problem. I can't hear you if I don't have the preview on.
Yeah, I found that if you do just screen share, if you make a scene and it's only screen share, you get no audio. So what I do is I put a second insert of you and your screen share, and then I can hear you talk. So it's like you have to fake it out. When you do a screen share, there's no audio.
Okay.
Isn't there dedicated software to do this? I mean, other people can't be having this problem.
Yeah, it's called XSplit. You know what? We should have gone with OBS. It doesn't even cost anything.
Well, that's kind of my point.
I'd assumed that because XSplit was commercial and $200, it would be really good and not have headaches. Like, I looked into OBS first, and it seemed like it would be difficult. But in
it seemed difficult to me too. Yeah. No, I looked at it and I went, boy, this is just another can of worms.
It is.
All right. So actually, it says we have 7 viewers. Is that right?
Mike Fikes is on. Our dedicated crew of.
Oh, Mike said hi. Hi, Mike.
Hi, Mike.
We're troubleshooting. We're actually streaming from another site.
I'm streaming from my computer instead of Bill's today, but to the same channel.
Oh, somebody said hello. Hey, let's keep going. Hello. It sounds like it's. How's the audio, guys?
We're more than half an hour late, so we might shorten the show today.
Hello from Colorado.
We've kind of given up and said we're not doing it, but since you've all jumped on, we might as well have a little chit chat.
Well, Mike just said every time you're not live, you are live. Mike, we did know we were live. We just didn't know anybody could see it because the stream analytics is frozen. So I can't see the screen analytics when Ben's streaming, evidently.
Same people on. That includes you and me, Bill, I think.
Yeah, plus we had a camera fail already today. Here, so while we're doing this, I'll hold this up and just say, hey, does anybody know what that is? Ooh, 3D house of... This came out of an old radio, a 6-volt positive ground radio.
It's MRE for engineers. You have to have a can opener and then you can suck the contents out.
You laugh. I still have my can opener from 35 years ago, my P40 for opening sea rations. I have it on my dog tags. I have it on a ring with dog tags. I had to stop carrying my dog tags because my Social Security number's on them. Back in the day, the Army was that was your Army ID.
Wow.
Yeah.
Yeah.
So if you got captured, they would slash your credit. Yeah, you had to worry about that.
Well, back in those days, I'm sure people had the national debt was not a crisis like it is now.
Yeah.
And money was still
any updates on the Discord or anything? Hey, somebody's asking about Discord. Is that the way to go? Maybe. What'd you and I say about that?
Wes, we said we were going to set up a diff. I keep hearing myself in echo. I'm the only person who gets echo from me, but it's the way I need to hear Bill right now.
I'll turn off audio preview.
Yeah, but then I won't hear you because I'm hearing you through that.
Oh, wow.
So let me do something. Let me turn Skype back up and turn audio preview off.
Yeah, I was going to say, because that's a full second behind or more.
Give me a second here. I'm turning audio preview off.
Yeah, I'm so fed up with YouTube that Discord sounds good, only I don't know anything about Discord, so that's why it sounds good.
Keep talking, Bill.
All right. What should I talk about? Oh, hey. So the thing I held up was what's called a mechanical vibrator. And basically, especially in the 6-volt days when they needed like a higher voltage for weight for it, tubes, you would use this to create the higher voltage. You would oscillate the DC going into a transformer, and it was ugly and had inductive kick and everything. But this is how you made the 170 volts you needed for your small tubes to work in your radio. So if you think about how do you turn 6 volts into 170 volts back in 1952 or earlier. Hey, somebody just said Adafruit's gone to Discord. That's pretty. That's a good recommend. That's a good credential. Ooh. We were talking about these earlier while Ben's working. Anybody ever use one of these? This is how I got interested in electronics. I had a 101 kit. This is, mine was 2 transistors. This has came out a couple years later. It's got LED 7-segment, little transformer.
I love those things.
A little relay, so you can build your own vibrator that we were just talking about.
I had that. I don't know if Bill, if you said this while I was not hearing you or not. You're still getting my audio, right?
I am.
Okay, good. I had the 200 in one. It was the first thing I ever got when I was 8 years old was a soldering iron and a Dick Smith kit for a multi-vibrator that flashed in LED.
Yeah, see, they didn't have LEDs when I was a kid.
And then the next birthday, a year later, when I turned 9, my parents bought me the Radio Shack 200 in one, which had this cool plastic molded front panel with a meter dial in it, like a voltmeter, and it had an LED 7-segment LED on the front and buttons and LEDs on the front, but it had a bunch of CMOS chips, which was very brave of them back in the day to put those there in cardboard with springs for kids to touch. They must have known, half of these are going to get static damage within the first 6 months. But actually, it turned out to be very robust, and I had that thing for years and years, and ended up tearing the whole thing apart and pulling the chips out of it to use in other breadboards and circuits. And I regret that.
I had a capacitor laying around that I recognized from my original board, and it laid around for years. But I actually troubleshot. I broke one of my 2 transistors. I know that I probably put a voltage in the base without a resistor. And we all know you can't do that, right? It's a diode short to ground if you don't have a resistor in series. And I actually went down and found an SK replacement for my 2SA transistor. So it became my first kit I learned on, but became my first thing I ever troubleshot at a transistor level.
Yeah.
So somebody's saying they used the snap circuits, brain crawler. Cool.
And now
that's too bad.
There's a really good case. I still use breadboards here and there, but mainly it's because, and let me show you what I've been designing this week, or designing while I've been on the break.
Yeah. Show us.
Let me share my screen. Let's see which.
Oh, this is great. I can lay back while you do all the screen sharing now. This is cool.
So there's my cooks and my Skype call with you, but here's Fusion. So this is what I designed in my holiday vacation time. I'm still working on it. I haven't fully laid out the board yet because I had to do a lot of library work to create some of the parts. So here's my latest clone stomp box for a guitar. And I'll double click on the schematic so you can see that. This is I'm calling it a full clone full drive because it's a clone of the full tone full drive, which is an octave up fuzz pedal.
Yeah, see if you can expand the schematic so it's easier to see when you get a chance. There you go.
So I'm zooming in. So I had to build a bunch of these connector symbols and footprints in the library. And so this kind of circuit is fun to do because it's all discrete. It's 100% discrete electronics. It's always kind of fun to design because you're not worrying about massive bulk editing or any of that, but you can also prototype it on a breadboard, and it takes a while. I'm not going to bother doing that because my time is worth a lot, so I'm just going to design a PCB. But what I like to do for things I haven't built yet is design in some additional, because boards are so cheap now, right? If you go to Osh Park or
Oh yeah,
PCBWay or
I don't breadboard anything anymore.
I always add a little bit of extra space or extra pads and connections that I can use as kind of pseudo prototyping area in case I get something wrong
Right.
and want to make adjustments. So this is a
So yeah, I can't see the chats while I'm looking at your board up close. Hey Q1, I'm surprised you don't need a bias resistor for the base like you.
Well, that is a really cool trick. I'm glad you mentioned that, Bill, because it's biased.
Okay.
It is biased through this whole
By
network.
the.
So there's pull down through this 100K.
Oh, there it
But
is.
it's
Yep, I see it.
disguised. This is the pull up, this 100K and that 100K. So here,
Very good.
the DC voltage so it's a 2-transistor circuit, and the DC bias is incorporated into that 2-transistor. The first one's really just used as a buffer and a gain stage, so it's got fairly high gain, a little bit of emitter feedback there with the 1K resistor.
Right.
But the DC bias comes through this 47K pull-up on the second transistor, the 0.6 volt drop there, through this 100K and the pull down there. So, and then this circuit here provides some AC feedback characteristic. So it's a bit of a filter as well. And then so that's a low pass filter.
Right,
Negative
right. I was going to
feedback,
say
low
it's
pass
following
filter.
it
Yep.
slowly. Yeah.
And so the DC bias and the gain is somewhat set by this resistor, and this 47K here is really to provide the DC bias to the base of the front end transistor there. So it's a two-stage inverter, you know, and then off to this one. So this second stage is also a differential. So as this transistor turns on, the collector voltage drops and the emitter voltage rises. So we get it. This is a phase splitter as well. We've got some gain in a phase splitter, and then we're rectifying, half-wave rectifying the two phase out of phase signals.
Right.
And when we mix those together, you get something close to a triangle shaped waveform that comes from the guitar, but it's something close to a triangle shape that's an octave above what the note is that you're playing, but there's still a lot of harmonic content. The fundamental is still the guitar note, but you get a very strong second harmonic. Or is it called first harmonic?
And it's without doing a tracking generator or anything. It's just basically making a distortion of your original signal.
It's totally analog using rectifiers. And there's all sorts of other ways of doing this. Other circuits used a transformer, and they would drive the audio signal through a little transformer, and the secondary was a center tapped with 2 diodes.
Just the phase splitting. Yeah.
This one just uses a transistor to do it.
So you mentioned gain. So when somebody looks up the gain of a transistor, what should they be looking for? Because it usually won't say. Sometimes they'll say AV gain, but there's a parameter.
HFE.
Do you remember it? HFE. That's right. So once you learn that, it's like okay. And transistors don't have as much gain as people think they do sometimes.
What was that question?
That's why we needed so many in a row.
I was just glancing at the.
Hey, that's a cool rubber band feature you just showed.
Oh, yeah. I didn't mean to do it then, but yeah, you can just grab and drag things.
But it's cool.
Yeah, it's cool if it's what you want.
You know what I don't. You know what I don't like in a CAD is what I call the suicidal move. Like if you move a part and it shorts every input together, you better hit Control Z quick because you can't undo it. And so some CAD stations allow you to like move, and if it overlaps, it'll query you to see, well, do you really want to connect all 26 connections?
I know, it should warn you. That's a really good point, actually. And as a product manager, I'll make note of that if someone does something that's going to fundamentally change the connectivity of the circuit in a radical way, then it should give them some kind of hey, is this actually what you meant to do? And
Right.
they can check a box to say, don't warn me again if they get annoyed by things like that. So they can
Right.
make it go away.
Or I've seen in the box where you can check it and say, don't automatically make new connections, is how they dealt with it. Like, I'm trying to think of the CAD that did that.
Yep. So
because now the problem I have with Altium then, if I want to bring in a part, but I don't want it to make suicidal connections, on other CAD systems, you can lay it off the sheet to the right or left or something. But Altium says, no parts off the sheet. So I don't have a scratch area, and I never did use the buffers like they talk about. You know how you could have multiple paste buffers.
Oh, yeah, and there used to be a favorites panel. I don't think they have that anymore because most people didn't know about it, even though it's really useful. I think a lot of things like that got slashed because they are seen by developers as technical debt. It's kind of fair enough if you do the analytics and nobody's using it, why keep it around? But sometimes the problem isn't that no one's using it. Sometimes it's that no one ever told them it was there, or just it wasn't discoverable, and it could be really powerful, you know?
Right. Hey, somebody's asking if Eagle still exists.
Of course it does. And if you get a Fusion 360 subscription today, you get Eagle desktop with it. Or if you go to the Eagle website at Autodesk and you want to buy and download Eagle, you get Fusion 360 with it, because Fusion 360 ultimately the medium long-term plan is Fusion 360 will be the way you do electronics from as far as Autodesk is concerned. For today, Eagle's still supported and still available. But you get both because Eagle works with Fusion 360, so you can get these mechanical assemblies like the one I'm looking at here. So what took me all the time and why I haven't routed my board yet was in the mechanical workspace, and I'm not a mechanical engineer, so I'm still learning how to drive Fusion. But actually, it's probably the easiest modeling tool I've ever used for building these part models. So I had to make these detailed connector models, and these are Cliff. These jacks are made by Cliff in the United Kingdom. They're kind of my favorites for audio. And here's the actual real world one that I have in my shed. But I did these from the data sheet directly, and there's the Neutrik. This is the Chinese-made Neutrik version of the same thing. And
yeah, I haven't seen that shape before. That's cool.
I thought these are a good challenge for me to force myself to learn how to use the 3D modeling part of the tool. So that's kind of what I spent time doing, which is really cool. I've got this library, and because I'm using XSplit, my computer's grinding here. So
yeah. Hey, did you see the book that when we were talking about transistors? This is a hardbound TI book, and it's bookmarked, and so I just had to see what the last transistor I used, and it was a 2N4391, which is a JFET. This is back when JFETs were like, ooh, it's a transistor, but it's not.
Well, yeah. The cool thing about
JFETs are obviously junction FETs.
The cool thing about FETs is they essentially behave pretty much synonymously the way vacuum tubes did. So
right, it's a voltage device, not a current device.
And they work by the same principles, just in solid state, not in vacuum.
Right. So, hey, Mike had one of our people that my friend and that's watching here today. He did what did he do? What were we talking about? I'll think about it. There's a 2-dog delay before my brain remembers what I was thinking about. A dog delay is about 4 seconds, by the way.
I didn't know that.
But we were talking about. I forget what we were talking. Where does that come from? Oh, I have a dog that when you go to let him through the door, he takes about 4 seconds to look and go, and then he runs through the door. And so we call it a dog delay because you have to stand there for 4 seconds while he figures out that the open door means him. So yeah, Mike, it wasn't the triangle. What we were talking about gain and transistors the other day, and I forget what we were. Oh, Mike, I remember what it was. You built a video buffer using, I've used like the AD812 and stuff. But what I was going to tell you is your op amp is probably a current mode op amp, if it's a true coax line driver 50 ohm, versus a voltage type of op amp.
So like
and they are different critters.
So meaning
Yeah.
transimpedance amp? Something like
typically,
that?
And it means the gain transistor, the gain resistor, usually they'll tell you what the RF switch came later, but usually they'll tell you what the best gain resistor is. So it's not like an op amp where you can choose almost any input resistor and any gain resistor. In the AD812, it's 352 ohm that you use for the gain. But so op amps themselves can be both voltage or current mode. So it's as life often is, right? Hey, a working stream. Yes, Chris, we had to completely flip it on its end. I broke a camera, but we got a replacement camera working.
So what else did we want to chat about today, since we're actually doing this?
Well, I liked seeing the fusion. So, tell us a little. Oh, that's a cool. Can you expand that so we can see it full size?
Yeah, not shrink it. Oh, I see what you mean.
Yeah, just grab the corner and pull it open is all I do. I don't instantiate a new stream.
Sorry for those who prefer a purely electronics show, but this is an electrical connector, and this is why I went to Autodesk.
How long did it take you to make that?
This one took me a couple hours. But now that I know what to do, I could do the same thing probably, in 20 minutes. And I intend to use this as an example of a how-to video. But basically...
Yeah, that's beautiful. I like the shadow.
This is cool because I can start with a footprint in 2D, right? So going back to the library here. Okay, so I can start with a footprint. It's a little crunchy here. Maybe I should have gone back. I've got too many things running right now with XSplit.
Well, I see the dip pattern in dotted lines. Yeah.
Yeah. So let me see if I can find. Where is it? I've added hundreds of capacitors to this library, but I double-clicked on the wrong thing.
I spent 4 hours the other morning just fixing something like 5 capacitors and two other things in Altium. And it's like, oh.
Yeah, this is a little on the slow side just right this minute because my tiny laptop's not coping.
It's doing everything.
Not coping with running this and XSplit together. I've got to figure out how to improve that.
Well, what you could do is use your other computer and no, you'd still need XSplit on it. I use RDP.
I can use one of the other XSplit utilities to stream from one to the other, maybe.
But you'd still have XSplit running on both. What I thought.
So what I wanted to say was, you can see if I let me hide the actual 3D body. Hide it there. You can see there's.
I'd pay to watch you make a part like
there's
that.
These two-dimensional sketch objects actually come from the footprint. So I can start with the.
Lost your audio.
Hello.
Okay. There, you're back.
The 2D footprint I can start with in the 2D PCB library, and just lay out the pads. I could use an IPC wizard is built into this for different kinds of things. It'll do the 2D footprint and the 3D together. But for things like connectors, I'm going to start with the 2D footprint layout according to the datasheet, and the pin positions and everything. But the cool thing is I can then derive a package from that, and it puts me in this mechanical modeling workspace. And this sketch, the silkscreen sketch, shows me objects on the silkscreen. The pad sketch has all the pads laid out, and the text sketch has the designator and name, or the name and the value fields. And I can I could actually extrude 3D from those even if I wanted to, but
Right.
So I can use these objects in the 3D modeling workspace. So if I go to Solid, I can create a sketch, I can extrude, I can do all the normal solid modeling things. But Fusion also has this really cool, has sheet metal capabilities. So what I did for this one, let me re-enable this view, and you can see the entire, I don't think I enabled the history. Did I not enable history on this?
How long did it take you to make that part? You said like several hours.
Because I didn't know what I was doing, and I was using sheet metal for the first time. It took me about 2 hours. About 2 hours.
Oh, that's excellent. It would take me about 2 days.
I'm gonna do it all over again from scratch and record a video, and you can see it can be done in once you know your way around the tool, you could do it in about 10 minutes or 20 minutes a part like this. So I started with a profile based on the datasheet dimensions. And let's see if I double click on that or make it visible. What can I do? I'm kind of lost here. I can export all these sketches as DXF as well. If I go look at it, I started with this profile that had this was all done from datasheet dimensions directly. And then let's look at on this one. Then I did a sideways profile also based on data sheets for some cuts. So I used this sketch, the front sketch first, to generate the main body, which was this part. Then I used the second sketch to generate the end of that, and that merges those together. Then I have these other twos, which were just separate bodies made for the fiber compression washers that go on this connector. I haven't added the nut yet, and then all of these other bodies are sheet metal. So I used the sheet metal flange. I used the contour flange. So I drew the contour. Let's go front facing. That's hard to, let me go to the front. And rotate that.
Yeah, I'm not seeing the Fusion right now. Because you don't put it in the stream to me, I have to watch it on the actual
YouTube
output.
I'm sorry. Yeah. So I did the contour of that part, and then used the sheet metal modeling to create. So these are actually modeled as how they'd be built in a factory. They're actual sheet metal. And I can, and the cool thing is, even though this is a single 3D model, any individual body can have a physical material assigned to it. So I did that. I assigned all the physical materials, and that means when I go into the photo rendering workspace, after I've modeled my entire printed circuit board, I want to generate what looks like a photo of the finished product. I can bring that in, and it applies the actual material properties to the ray tracing.
Right.
So it's fun. It's not, it's not electrical engineering, but it's sort of fun to do something a little bit different.
And you made this part because it wasn't readily available. Is that a correct assumption?
It wasn't one that was in it wasn't in the readily available libraries, but it's a part I use all the time for a lot of my projects. Particularly all my guitar.
So where do you get your 3D parts from? Somebody just mentioned they're online, and so you and me, basically I Google 3D and resistor and things like that, and it takes you to the same 2 or 3 sites.
Well, the best bet is to go, and Dave Adams agreed.
3dcontent.
Dave Adams.com. You go to the manufacturer first. So particularly connectors.
Right.
You go to Samtech.
Particularly connectors.
Go to Samtech, go to Omron, go to TE Connectivity, go to any of those marquee connector manufacturers provide 3D models for almost all their products as IGES and STEP files. But there's 2 things about that. And of course, for a lot of others, you can go to GrabCAD or 3D Content Central, which I use a lot as well. But I want to model these ones myself because firstly, this particular cliff jack is not exactly the same as a typical Neutrik jack. And nobody else has made a model in any of those free download places. Cliff UK do not make the 3D models available for download. That's their intellectual property. So they give you a data sheet and a drawing, but they don't give you the 3D model. If I was a big company and signing an NDA, they might do that. So that's an option.
Right.
So I just
somebody mentioned
did it myself.
Oh, go ahead.
But the other reason is Step and I just are not efficient file formats. They are useful, and they give you color. They don't give you actual solid material, and they don't give you. And they're basically the way Step defines something is like a set of surfaces flying in unison,
right?
Flying in formation.
Yeah.
And
Yeah.
so you've got no real solid information. This, in my library, by modeling these natively in Fusion, it retains that link to the native model. So it's not a Step model, it's an actual Fusion model. And that means when I go to do thermal analysis, also in Fusion, it's got the material properties assigned, and they will behave like those real materials thermally. And also in rendering. So you can make LEDs in your Fusion library, and you can put a chip inside the middle of the package. You can make it translucent. Step doesn't support translucent bodies, not properly, and most tools, most other ECAD tools won't show translucency from a Step model. They'll just make it like solid white or something.
Shaded. Yeah. Yep.
But in Fusion, you'll get the translucency, and you can put a chip inside and give it an emissive property in the materials library. You can make it an emitter.
Oh, cool.
And then when you do a render, it actually shows you the light source. It works as a light source in rendering, so you can test your light pipes in the rendering workspace.
Wow.
Which is really awesome. So
wow. Can you see the light shine through the back of the PC board? Can the PC board be given a certain amount of translucentness?
I think there's a way to do that, but I haven't tried it. I think Matt Bergeron, who wrote the code to do all of this, or who runs the team that writes the code to do all this.
Right.
He made stuff like that possible, and he's generated some renders in testing all of that looked pretty phenomenal. He even went as far as detailing solder fillets on some surface mount pads. He had it model and render shiny silver, solder fillets.
Right.
And I think, for DFM, like that's eye candy to us, and we want to do it because it looks cool. But actually,
for
there's
DFM,
a legitimate
design for manufacturing.
There's a legitimate DFM. There's a legitimate DFM application, which I think ECAD tools should have, where if you tell it the stencil thickness and it knows the stencil aperture, and what you could have a library of different solder paste materials in use. You can tell it what paste you're using. It will actually output and render the fillet you'll get, and give you a warning if there's too much solder that it's going to beat up and run all over your board. I think that would be super cool.
Now, is there an IPC wizard built into Fusion for making footprints?
There is, and it's called the package generator. So here I'm building an MKT capacitor, and I'm just I'm fiddling around with this because this is also a project of mine. I'm learning. Fusion has this. I'll just show you really quick. I wrote this code. Fusion has a Python API and C++ that's totally open, and everyone who has Fusion can use it, and it's really well documented. So I was fooling around with this capacitor to start to get to learn the API, but that's completely off topic. Sorry, I'm just explaining why I'm halfway through building a model here. But there is, if I go to the package 3D, there's this link here, 3D package generator. And this one This is built using that API. This package generator is built by our team using that API. So it's basically got all the IPC 7351 defined land patterns for these different JEDEC packages. And we're adding more to it beyond IPC. IPC 7351 is great, but it only covers surface mount. So there's some additional things in here that aren't surface mount, like axial components, through-hole crystals. And I'm asking, and dips, I'm asking the team to add, there's a handful of other through-hole packages that people still use very frequently that we should have automated package generation for those. I don't need to walk through that. It's super straightforward. It's just like any other IPC calculator. You put in the values from your data sheet and it builds.
And maybe we can show one someday.
It builds like it's not rocket science. It'll build the footprint accurately to least maximum nominal courtyard standard. And it will give you a native 3D body, not step file, but native 3D model that can have actual material properties assigned.
Got it. Hey, so a couple of, the word cloud has come up a couple of times. Can you speak, for example, if you have a bad internet connection, will your Fusion still work correctly? And, somebody's asking, what about designs up in the cloud? And I don't want to confuse those things.
I just want to be real clear. Fusion is a client that runs on your computer, so it's got all the access to your CPU, GPU. And we've got a huge project this year to really ramp up performance, especially in schematic and PCB and library editing. But all of these things that I'm working on locally. They're on my hard disk and they're cached locally. And if I lose, or if I have a choppy internet connection, it'll still let me keep working. It just needs a little heartbeat connection every so often. That's I don't recall what the time increment is, but it's something in the order of 30 minutes or an hour or something like that. If you lose your connection, it'll let you keep working and save, and it'll synchronize your data to your cloud storage when it's able. So, and yes, the data will be in the cloud. That is true. But I've got news for you. It already is anyway, whether you like it or
not. Well, I was going to say there's a whole discussion we could have about that, because I do work that involves CGIS, which is FBI data, and everybody keeps going cloud, and I get to take them out back and shoot them when they say that, because you have to have a qualified cloud provider for that stuff.
I just realized everyone's just looking at my blank Fusion there. I get it. I mean,
I guess
it's a valid concern, and there's a lot of us engineers, not me personally, but a lot of engineers, people I know, work with companies that have a requirement, usually because they're a military contractor or something, but for whatever reason, they have a requirement that everything is local and that there's strong firewalls or no connection. And that will
it work in that instance?
Those companies will always exist and always have that requirement for the foreseeable future. I get it. For the most of us, though, that's actually not a large portion of the work to be done, and there'll always be some options in the market if you absolutely have no choice but to be disconnected from the internet to do CAD work. But that's not going to be Fusion. It might be Altium Designer. Yeah. It might be Cadence, or there's CAD tool vendors out there who will always provide an offline option, and they'll always market that loud and clear, especially because Autodesk is very loud and clear about being cloud and looking into the future being all about that and making that the best user experience. And so, okay, but you're not going to get the same design value or value for money, honestly. I won't divulge information that's proprietary, trade secret. But if you look at any ECAD vendor website today, we have, of course, you can have an offline version or an online version, and it's your choice. Look at the price, get the pricing, and you'll see what I'm talking about. You will be punished for being offline. Every software company in the world wants to be cloud and subscription based. That's just the way it is because I don't know, maybe
it's a recurring revenue model where you get to maintain your customer touch.
And this is my personal Ben Jordan's point of view on it and my way of talking about it, not representing Autodesk. It's just me personally, but I call it capitalist socialism. Because I'll tell you why. It's not a government charging you X to use their services. It's a company, right?
Yeah.
But the capitalist part of that is beneficial because if they don't delivering value, why would you stay with them? And ECAD vendors were terrible with this. The MCAD world grew up and was a lot more mature about it earlier than ECAD. MCAD companies years ago all kind of ended up standardizing on the same basic principles and therefore made it very easy to open data from different CAD tools. So I can go into SolidWorks and open an ideas file or a Pro-E file. I can go into Pro-E, open a SolidWorks file. I can go into Fusion, open SolidWorks or CAD. All of them can open AutoCAD files. And so the file format almost kind of became an industry standard thing, whereas in ECAD, the ECAD market is so much smaller than MCAD in terms of dollars, and there's so much investment required in making a good ECAD tool in history that all the ECAD companies did whatever they could to lock their users in. And the number one principle behind that is binary encrypted data formats and no reverse engineering allowed into EULA and legal threats to anyone who did reverse engineer it. And that still goes on, but that's a legacy of the past and the fact that ECAD was expensive, hard to do, all of those things. I think finally ECAD's getting to a place, and Eagle started this. Eagle was the vanguard of this, really, of saying, this is ridiculous, guys. Your data is your data, so it shouldn't be in some obscure, closed, encrypted format. You ought to be able to take it with you, and shame on us if we don't deliver enough value in our product that you don't want to keep using it. So on one hand, we're like, yeah, we're subscription based and we use the cloud, but we're committed to delivering value, or you have every right to go somewhere else and spend $10 or maybe even $80,000 for a license for a perpetual product that has all these capabilities. But at least, you can buy it once and use it forever on your own disconnected computer. That's fine if that's what you need. No problem. There's people who will sell that. For everyone else, there's, Amazon's working to solve these issues as well. They have this thing called government cloud. And
which is what we use for Sieges. Yeah, that's where I was getting at, is there are ways to do that.
There are. And if it's good enough for the FBI, it's
probably good enough.
They have all your data already anyway. Maybe they don't have all your PCB designs and they don't care about those necessarily. But if they want them, they'll find a way to get them. So
they will. They will. NSA and them.
So
hey, you mentioned.
Yep.
Go ahead.
No, you go ahead.
Well, I was going to say, I was just going to do a comical insert. You mentioned flying in formation. We used to call helicopters in the old days 100,000 parts.
Oh my gosh, that makes me nervous just thinking about
it. Usually you hear that while you're trying to fly one, so it's.
Yeah, we have a saying I've heard around the halls of Autodesk. Well, it's not the halls anymore; it's the Zoom meetings.
the Zoom meetings of Autodesk.
But there's a saying I've heard that's kind of fun that I liked. It's like we're building the aircraft while we're flying it. We're building the plane while we fly it.
Fly it. Oh, there you go.
I didn't say that out loud. That doesn't mean the product's not finished. It means ongoing development. That's what it means.
Right.
Yep.
So we were going to talk about Quux today, but this was obviously a buggered up day, but that's still on our radar for next time.
Sure.
Quux being simulation software and PCB material. Now, real quick before we close up, what kind of hooks does Fusion have for simulation? If you're entering a schematic, I assume it's simulatable at some level.
Yeah. It's much like Eagle. It's also in Fusion. There's it's not XSpice, it's NGSpice based, which is the most youthful and aggressively developed Spice variant. So NGSpice came from XSpice, which came from Spice 3F5. And the benefit being NGSpice was enhanced to more easily. It's faster, but it also has hooks for doing mixed analog and digital simulation, state machine simulation, and various other things like that. I haven't really gone into it in Fusion yet, but it is right here. You can see it's a pretty streamlined workflow. You can add models to parts. You can do it here at the schematic level, or you can do it when you're building your parts in the library. You can link simulation models, Spice models to them. It'll take Spice 2, 3, whatever NGSpice supports, it'll take. So the latest BSIM models, and it's got a good waveform editor built in. Again, I'm not particularly flush with experience yet, but I'm getting there.
Right.
So,
and most CADs do, like Proteus was the one I used before Altium, and obviously both Proteus and Altium, if you're entering the schematic, it's fodder right into the simulation. It's useful.
Yeah, it means not reworking. Yeah. What do you use when you want to simulate, Bill, normally?
Well, I've been using LT Spice lately. My roots, though, is I used HSpice back in the day just because of it was some of the properties it had for transmission lines and things. HSpice could do a full nodal coax simulation as opposed to lump sum.
Yep. Someone was asking on the chat, can you import Altium files into Fusion? Not today. I'm working on that, but not as yet.
How useful is EDIF for something like that?
I will say this though. Altium has an ability to read and write Eagle files, so through that you can.
Right.
EDIF,
and that's one of the reasons I went to Altium was it does play nicer with other CAD systems.
Well, it has a lot of importers, let's say.
Yeah, say that. Yeah, whereas Proteus doesn't. Yeah.
What were you asking there, Bill? Sorry.
I'm sorry, I didn't mean to knock you off. You were responding to somebody saying something on the chat. I thought.
I like the comment that Quux is salt-free.
Salt-free.
Does that mean it's not?
But you had asked me what spice I use, and so LT Spice is the most recent one I've used.
Yeah, that seems to be kind of the industry standard, and
it's easy to grab.
I think a lot of engineers just use it because it's got accurate models and a really compelling library. The interface looks like it's from 1992, but it works. It's accurate.
It probably is from 1992.
It's well supported with models. That's the main thing, and LT invests a lot in it to make it free. Which is great, and
I never saw models for PC boards though.
No, and it's really only circuit simulation. Yeah.
Whereas Cooks, when we get to that, you can model a PC board, and Mike Fikes was asking about, that.
Cooks is good. The reason I like Cooks is it'll do RF and microwave. It'll do basic circuit simulation, but it will do transmission line simulation, which is mainly what I would use it for.
Right.
And it's very fast.
So, as we wrap up here today, so maybe if we look at Discord and then put the video later up on YouTube, we can do both, right?
Sure. Yep.
Yeah. So, because I don't want to lose the YouTube channel, and actually I wouldn't mind streaming to Facebook. In the mode we're in right now, it's possible maybe I can stream to Facebook and you can stream to YouTube simultaneously, or Discord or whatever.
Yep. Or correct me if I'm wrong, but XSplit can stream multiple separate streams at once, or only the one?
They were working and then it stopped. And so I don't know if the new version I'm on fixed it again. But when you and me first started, I was streaming to both, and then Facebook stopped working simultaneously.
Yeah, that's a shame. But we'll figure it out. All right.
Well, hey, my friend, it was good talking with you again. We're coming up on the 3:30 on the East Coast here, which is like 5 in the morning for you still, right?
It's
on the West Coast.
It's 12, coming up on 12:30. So we started half an hour late. So I guess we're finishing an hour in-ish.
Yeah.
A little less, but that's cool. And
hopefully it's just we got to get so it works every time. That's all.
Next week, let's talk more about simulation. We'll bring up Cooks. We'll look at some FDTD and see how much slower that is than using a SPICE-based engine.
Okay.
And then whatever else we come up with, and hopefully the week following that, I'll have this Stomp box prototyped, and I could maybe do a demo, or I don't know.
Yeah, somebody was asking for some power cords, so you'll get a chance to do a demo. I'm assuming.
I'll see if I can feed another audio in from the other computer, which has my amp simulator on it. It's a model. I don't have a real tube amp anymore. I love tube amps. I had insisted on using only a tube amp for the longest time, but I honestly got tired of breaking my back every time I got that thing out of the back of my car. So
right.
And I was messing around
That's what roadies are for.
I was messing around with plugins, and they just started getting so good and so realistic and so accurate with that, because instead of using a bunch of filters to artificially kind of estimate what an amp would behave like, they switched to using impulse responses, very long impulse responses, with like a 4,000 tap FIR filter. So they're super, super accurate at reproducing the real thing. And so what you do is you get a real amplifier with a real microphone in a real room, and you record an impulse response. So you send an input to the amp that's just like a step pulse, and then you capture and digitize the output of that, and that becomes an impulse response. That becomes your coefficients for an FIR filter, and that FIR filter then gives you the sound of that whole amp, mic, room setup. And it's very accurate.
Now, is that done as a VST? When you say you have an amp model, are you doing them as VST virtual instruments?
I can use them that way, yes. I can use a VST host program, but some of these applications now
are little standalone.
You can get them in standalone boxes. Like Line 6 really pioneered this, and AxeFX, Fractal Audio Systems, and a few other companies, Kemper in Germany, which is amazing. They pioneered all this with actual hardware that you can carry around. But I use a laptop, and I use it with mainly this German software from Native Instruments that's wonderful because it's got a good user interface. I've used that for years, and I'm very good at that. I know how to get good tone. So, but I still like to mess around with Stomp boxes in front of it.
Right. And I'm looking for I have a Steinberg Cubase.
Yeah, they invented the plugin standard.
There we go.
VST.
There's my Steinberg Cubase.
Yeah. So, yeah, perhaps
right.
a couple of weeks out we'll do a demo or something. I don't know. Only if people are interested. I don't want to do it if everyone on the call is like, oh, you're.
I'll tell you that electronics and music are the same thing. And the reason I got into engineering, or designing, I should say, and I was all of, my design to synthesizer when I was in high school, is because I was an Emerson, Lake and Palmer fan, and I could hear the relationships of the electronic music, and it's monophonic too. So it was easy to follow, all the sources and things mentally. So yeah, electronics and music are the same thing to me. And the guy that did the SID chip for the C64, he turns out he's a Keith Emerson fan. So without Emerson, Lake and Palmer, there may not have been a C64 as we know it.
You know what I didn't ask you about, but if you were aware of this amazing synth project that was published in Elector magazine in the 70s called The Formant.
Don't
it's
ring
a multi-article synthesizer. It's a big rack with modules. It's a modular synthesizer project, all analog, with digital control and control voltage inputs. So if you wanted to, you could set it all up to be MIDI controlled. But
right,
if you want to go back to first principles signal processing, you study a project like that because everything's there and all the descriptions of how everything works, all the VCOs, all the VCAs, all the VCFs, oscillators, all different kinds of oscillators, different kinds of amplifier topologies. So they've got compression expanders as well, and transimpedance amps, regular voltage amps, the whole 9 yards. It's all captured in analog synth. And just awesome first principles signal processing. It's cool stuff. So maybe we'll look at that one of these days.
And it's polyphonic?
It is. If you make enough modules, you can set it up however you want.
Okay. Yeah. Okay. So like an analog synth, you can bring more tone sources to the table and run them off the same control voltage and things like that.
Yep.
All right. Cool. Well, hey, everybody, thanks for sticking with us. Pretty much everybody that started watching finished watching. That's impressive. We'll look at Discord. We'll look at more into this fixing the YouTube thing. This actually worked, and maybe you and me can, like I said, stream Facebook and YouTube simultaneously next time or something.
Yeah, we try it. Let's give it a go.
Yeah, I have to fix my camera first. So, all right, now it's your turn to say to stop the stream since it's coming from your end. Actually, it looks like I can do it here as well.
Yeah, you should be able to turn off.
Thanks, everybody.
Yep. Thanks, everyone. Great to see you.
Yep. Good seeing you, Ben.
You too, man.
Okay, so